Hello, dear children, dear students. Today we have Proposition 29 of Book 1. If there be two parallel lines parallel to each other, and a line falling upon those parallel lines, that line will create, with those two parallel lines, alternate angles equal to each other, the exterior angle equal to the opposite and interior angle, and the two interior angles on the same side equal to each other. Equal to two right angles. Okay? So let's go here. If there be parallel lines and a line falling upon them, it makes alternate angles equal, the exterior angle equal to the opposite and interior angle on the same side, and the two interior angles on the same side equal to two right angles. Okay? So there's three little proofs within this proof. Let's do the first one. Let's prove that this is equal to this, that these two alternate angles are equal to each other, okay? So we're gonna do a reduction. If they're not equal, one of them is greater. If they're not equal, they're unequal. That is to say, one of them is greater. Let's say that this one is greater, okay? You can pick either one. Let's say that this is greater than this. Let's add this to both sides, okay? So now this and this are greater than this and this. Because this was greater than this, you added the same thing on both sides, equals, added to equals, the wholes are equal, okay? From our bag of knowledge sheet. Today we're going to use vertical angles are equal, proposition 15. We're going to use a straight line falling upon a straight line creates adjacent angles equal to two right angles. We're going to use fifth postulate, which states that if a straight line falls upon two straight lines creating interior angles less than two right angles, that those two lines will meet on that side and not on the other side. Okay, so let's get back to this. Given that these are unequal, and we're going to say therefore that this one is greater than this one, we're going to add equals to both sides. That's where we left off. Therefore, the whole is still greater than the other whole. If this is greater than this and this are going to be greater than this and this. Great. Now look at this and this. We have a straight line falling upon a straight line, making adjacent angles equal to two right angles, as we know from proposition 17. Therefore, these are equal to two right angles. And these two are greater than these two. If these two are greater than these two, and these two are equal to two right angles, these two must be less than two right angles. But we know from our fifth postulate that if you have a straight line falling upon two straight lines, creating interior angles less than two right angles, that those two straight lines will meet on that side and not on the other. So if these two angles are indeed less than two right angles, these two straight lines will eventually meet over here. But it's given that they're parallel. So they can't both be parallel and not parallel at the same time in the same respect. That's a contradiction. So it cannot be, the premise that we granted, therefore, cannot be true, that this is greater than this. And we could do the same thing on the other side if you say, well, let this one be greater than this one. They would end up meeting on this side for the same reason. So if this is not greater than this and it's not less than this, it must be equal to it. That's the first part of the prop we wanted to prove, that this is equal to this. Alternate angles being equal. Now we need to prove that the exterior angle is equal to the alternate and interior angle. Watch this. Two straight lines falling upon each other, we know that they create vertical angles equal. So this is equal to this, but this is equal to this. So we have two things equal to the same thing. They must be equal to each other, okay? So this exterior angle is equal to this interior and opposite angle. The second thing we wanted to prove. Now we want to show that this and this are equal to two right angles, that the interior angles on the same side are equal to two right angles. Well, this and this are equal to two right angles because we have a straight line falling upon a straight line, creating adjacent angles, and they are equal to two right angles as we proved in proposition 17. So therefore this angle and this angle, because you have the straight line falling upon this straight line, creating adjacent angles equal to two right angles. So this and this are equal to two right angles. Well, if this equals this, and this are equal to two right angles, let's add that to this as well. So this and this must also be equal to two right angles. Because this and this is equal, we added the same thing to both sides, and in this case, this and this are equal to two rights, therefore this and this must be equal to two rights. Because two things equal to the same thing are equal to each other, therefore the interior angles are also equal to two rights. So we showed that if there be two parallel lines and a straight line falling upon them, it creates alternate angles equal, the exterior angle equal to the opposite interior angle, and the two interior angles on the same side equal to two right angles. Quod erat demonstrandum. Thank you very much. Bye-bye.